Hello students, welcome to Educate. In the last class, we have discussed about till the nucleophilic substitution reaction in haloalkane. But in that class, we have not discussed about the stereochemical aspects of nucleophilic substitution reaction. About that, we will discuss in this class. Let's see firstly, there is a term that is optical activity. Okay, so first of all, you just imagine there is a point. Now, how much line can be drawn from a point? Think. So, from a point, infinite number of lines can be drawn. In the same way, along a line, a number of plane will be there. That means suppose this is a line here. So this plane is perpendicular to this line. This plane is also perpendicular to this line. This plane is also perpendicular to the line. This plane is also perpendicular to the line. So along a line, there will be infinite number of planes. Okay, and what is that? What is there then after is infinite number of planes there will be. So before that also one thing I left to tell. What is transverse wave and what is longitudinal wave? Transverse wave is the wave in which the constituent particles vibrates perpendicular to the direction of propagation of wave. That is, transverse wave is the wave in which the constituent particles vibrates in perpendicular to the direction of propagation of wave. Like that, when you will jerk a string, the constituent particles like this one here, when you will jerk the string, here is the end fix, you are jerking from here. So constituent particles will vibrate to and fro perpendicular to this line. Wave will propagate in this direction and the constituent particles will oscillate along this line. So this line and this line is perpendicular to here. So that is transverse wave, and longitudinal wave is the wave in which the constituent particles vibrate in the same direction in which the wave propagate. Transverse wave, the constituent particles vibrates perpendicular to the direction of propagation of wave, while in a longitudinal wave, the constituent particles vibrates in the direction of propagation of wave. A best example of transverse wave is light wave, and best example of transverse longitudinal wave is sound wave. Transverse wave, light. So which type of wave is light? So light is a transverse wave. Light is the example, and longitudinal wave. Example of longitudinal wave is sound wave. Okay, that is. So what happened? One point is clear, that there will be infinite plane perpendicular to a line, and light is a form of transverse wave. Now let's see, in the ordinary light, that is light emitted by any source, that will be in ordinary light when there will be no modification, like light emitted from candle, light emitted from the sun, star, or any other source. That is here, but not about the especially designed electronic utensils. About that we are not discussing. I am telling about the ordinary source of light, like suns, stars, candle, and so on. In the ordinary light, that constituent particles, in ordinary light, the constituent particles vibrates in all the plane which are perpendicular to the direction of propagation of wave. In ordinary light, the constituent particles vibrates in all the plane perpendicular to the direction of propagation of wave. When that light passes through Nichols prism, then the constituent particles vibrates in a single plane. In ordinary light, the constituent particles vibrates in all the plane which are perpendicular to the direction of propagation of wave. And when that light passes through Nichols prism, then the constituent particles will vibrate in a single plane. That light obtained will be called plane polarized light. Okay, that is plane polarized light. And when that light passes through a Nichols prism, when that particle will vibrate through a substance and the plane polarized light will bend either towards left or towards right. When the constituent particles propagate and the particles, that means the plane in which the constituent particles oscillates, that bend towards right, then that compound will be called dextro-rotatory compound. And when the substance will rotate the plane polarized light towards left, then that substance will be called levo-rotatory compound. And if there will be no optical activity, that is, the plane polarized light neither bends towards right nor towards left, then the substance will be called optically inactive substance. Okay, so suppose here this is light here. So what happened? Firstly, in that light, the plane constituent particles vibrates in all the plane which are perpendicular to the direction of propagation of wave. Now this light passes through a Nichols prism. This light will passes through Nichols prism. This is the direction of propagation of light. So now passes through the Nichols prism, then constituent particles starts vibrating in a single plane. It is ordinary light. This one is Nichols prism. This one will obtain, that will be called plane polarized light. And now when there is a substance and the constituent particles will bend towards right, suppose this one. How to predict right? In which direction? That means when you are going in this direction. Suppose in east you are going. So east you are going. So right, when you bend towards right hand is there. So that will be like that. Like that you will have to predict. So this plane polarized light, if rotate towards right, that means plane polarized light bend towards, then this substance will be called dextro-rotatory compound. Okay, there is a substance in this container and that's here is dextro-rotatory compound, means this substance rotate the plane polarized light towards right. That is here in which direction you are going, just predict your right hand, and in that direction if you bend, that will be called dextro-rotatory compound. Okay, that is here. That was about what is optically activity. Okay, now about that optical isomers you have also studied in the 11th class. What is optical activity? So what is here? That the dextrorotatory compound and the levorotatory compound. Both will be optically active compound. But optically, the substance which will neither rotate the plane polarized light towards right nor towards left, then that substance will be called optically inactive substance. Okay. So how to predict a substance will be optically active or optically inactive? That's the question. How you will predict that a substance is optically active or optically inactive? So the most important criteria to determine that the substance is optically active or optically inactive, in that case you will have to watch out in the substance, that means in the compound, is there any asymmetric carbon atom? If there will be asymmetric carbon atom, if there will be a symmetric carbon atom in the compound, then that compound will be most probably optically active. I am telling you here because at your level, when you will do the examination till IIT main or the NEET or this one, but not I am telling about IIT advanced, IIT main only. So during that course, there will be a question that among these compounds which will be optically active. So you will have to watch out that in these compounds, that means among these compounds, which carbon is, that means in these compounds, which compound contain asymmetric carbon atom. Okay. So if there will be asymmetric carbon atom, that compound will be optically active. Now question arises, what is asymmetric carbon atom? So carbon atom which will be bonded to all the 4 different atoms or groups, that will be called asymmetric carbon atom. That means the carbon atom to which the 4 groups or atoms bonded will be different, then that carbon will be called asymmetric carbon. Let's see here as for example. Let's see. Watch out about this carbon. In this carbon, that is bonded to 3 hydrogen. So all the 4 atoms attached here are not different. So this carbon is not asymmetric carbon atom. Watch out here, this is the hydrogen, so what I have bromine. Now to this carbon atom, one group attached is ethyl, one is methyl, one hydrogen and one bromine. So this carbon is asymmetric carbon. Asymmetric carbon. This carbon is called asymmetric carbon because all the 4 atoms or groups bonded to that carbon is asymmetric. That means all the atoms or groups bonded to this carbon is different. That's why this carbon is asymmetric carbon. Okay. One is also concept here is, so this compound will be optically active. Optically active. But suppose this compound, so this carbon here, all that means 3 hydrogen atom is same. So this is not asymmetric carbon. This carbon, in this carbon also there is 2 hydrogen atom. So this is also not asymmetric carbon. So this compound will be optically inactive. Because this compound is not containing any asymmetric carbon, that's why this compound is optically inactive. And in this compound there is one asymmetric carbon, then that's why this compound is optically active. Okay. Now then after this, chiral and achiral molecule. What is chiral molecule? What is achiral molecule? Before that, when consider about when you will watch out your right hand in the mirror, then that will appears like left hand. Are they superimposable? That is not. Someone will tell yes. No. What is here? When you have to predict that they are mirror image of each other or not, then you will have to rotate the mirror image through 180 degree, and then after we'll have to keep. So here this portion is not covering fully this portion. So that's why this that means your left hand and right hand, that means here is not mirror image of each other. Okay, so chiral molecule are those molecule which forms non-superimposable mirror image. That is called chiral molecule. And just predict why your left hand and right hand, they are not superimposable. Reason is that the finger of your hand are of different length. The length of all the fingers are different. That's why your left hand and right hand are not superimposable of each other. In addition to that, when you consider about this graph, this one here, shape of your this, when you watch out this portion and this portion, here that is not symmetrical. If you cut this one into equal half, then this portion and this portion are not same. So that is here also there is no symmetry. So that's why your left hand and right hand are not mirror image of each other. But watch out about the glass. Just take a glass. So when you will watch out its mirror, its image in the mirror, so it will be also like that. Now when you cut this portion here, cut this portion, then this portion and this portion are symmetrically. That means this portion can be fitted in this portion also. So this one are symmetrically. When you cut this glass into two half like this, I am not telling like this, I am telling like this longitudinally, I am telling, not transversely. So when you will cut this one longitudinally, then this portion and this portion symmetrically. That means if you will keep on this one, cut this one, if you will keep this one, by rotate, obviously you will have to rotate through 180 degree. Then this portion will fit in this portion. So that is symmetrically here. So its mirror image will be like that here. So if you rotate through 180 degree through the mirror image and then after keep there, so this portion, your back glass will not be visible. So your this one here, because here is symmetrical structure, that's why your glass is forming superimposable mirror image. Okay, so the important criteria to be a chiral and achiral molecule is that if that molecule will contain asymmetric carbon. If the molecule will contain asymmetric carbon, then that molecule will be chiral and that will be optically active also. So this molecule is optically active and that is chiral. And this molecule, that is here, because this molecule is not containing any asymmetric carbon. This molecule is not containing the asymmetric carbon. So this molecule is optically active as well as achiral. Okay guys, now about the enantiomers, what is that? Enantiomers are the molecules, whose property will be, enantiomers will be the molecules whose properties will be different. That is optical activity. Properties in terms of optical activity will be different, but their structure will be same. The molecules whose structure will be same but different optical activity, that will be called enantiomers. As for example, glucose and fructose. Glucose and fructose, they are enantiomers of each other because glucose rotate the plane polarized light towards right and the fructose rotate the plane polarized light towards left. So they are enantiomers. That means the molecules whose molecular formula will be same, but The molecules whose molecular formula will be same, but optical activity will be different. That is, if one rotate the plane polarized light towards right, then the other will rotate plane polarized light towards left. That means here, if one compound will be dextrorotatory, then other compound will be called levorotatory. So that will be here called, enantiomers. Chirality means the important condition to be a chirality is molecular asymmetry. Okay, that was here. There is something more. If you will study that, then you will realize that this portion is not difficult. Here, same here as for example given here, your left hand and right hand. Your left hand and right hand both are a mirror image of each other. When you will watch out on the mirror, this portion appears like this. That means just watch out here. If in the mirror, if you will keep like this, so if you will suppose keep like this, so this portion, that means front one will be front, then after in this manner there is in this x-axis, in that manner there will be in the x-dash axis, that is the mirror image. But when you rotate your mirror image, one you rotate through 180 degree, and then after keep this one over this, so that will be not mirror, that will be not superimposable. Same in case of your feet also. In feet, your different portions, that means different fingers will have different length, as well as there is no symmetry. There is no symmetry. So how? Because suppose cut from anywhere, this portion and this portion are not same. So there is not symmetry. Same here, cut here, this portion is not same. So there is not same. So that's why their mirror images are non-superimposable. But when you consider about the circle, here this circle, so this circle will be same here as this portion is here, as this portion here. Suppose this portion here, so same mirror image formed here. In what, through which angle it is towards this side and this side, that is here also. So they are a mirror image. And when, since there is not this one here is symmetrical structure, when you cut this portion, then this portion and this portion will be same. When you cut through this line, so this line and this line will be same. So there is symmetrical structure. There is symmetrical structure. That's why when you rotate this one through 180 degrees, so that will be same. And when you will keep this object over this mirror image, then this portion will completely cover this portion. So that is here, it is superimposable mirror image. In the same way, in another glass you take, in this glass, cut this portion. So this portion are same. So there are mirror image forms this bulky portion. So this bulky portion, in which manner there is in the z-axis and z-axis, in that manner there is mirror image. In which manner there is this one, in that manner also there will be mirror image. Now when you cut this portion, so this portion and this portion are same. So that means there is symmetrical structure in this compound. In this compound, the structure is symmetrical. So when you rotate this mirror image through 180 degree, so same type structure will be there. Same type of structure will be there. So when you will keep this object, this glass over this glass, so this glass will completely cover this glass. So this one is forming superimposable mirror image. Because this structure, symmetrical structure is there. That means the symmetrical object, that means the object which are symmetrical, the symmetrical object will form superimposable mirror image, and unsymmetrical object forms non-superimposable mirror image. Okay. Now let's see here. Watch out on this molecule. That was about the object. Now consider about the molecule. Here is OH. So here is OH. So same hydrogen will be in front of that, oxygen this side, which is below. That means dashed ways. So it is below. So this methyl is also below in the mirror image. This methyl is towards the observer. So this methyl will be also towards the observer. Here hydrogen and OH is on the same plane. So is on same plane here. So this molecule is symmetrical. That means this molecule is not containing asymmetric carbon atom. Why? Because this methyl group and this methyl group is same. So, hence we can say that all the 4 atoms or groups bonded to this carbon is different. So, the atoms here, two group are same. So, this molecule is not containing any asymmetric carbon. Here also, because this carbon 3 methyl group here, so that is not asymmetric. This methyl is also not asymmetric. Now about this carbon is also not asymmetric as this methyl and this methyl is same. So let's see, firstly goes on the mirror image here. So OH will be here this side. This is the mirror. It is front side. So it will be also in front side. Below one will be at the below. Above one will be at the above. And hydrogen here is making this angle. So it will be making this angle. Now you rotate this molecule through 180 degree. So 180 degree you have rotated. So this OH on this side, the methyl which was below that comes above, and which was above that will goes below. Angle was here this side, so now rotate, so that will comes this side. Now keep this molecule over this molecule. Then methyl will be over methyl, this methyl will be over this methyl, this hydrogen will be over this hydrogen, and this OH will be above this OH. So this one, when you keep this molecule over this molecule, then the above molecule will completely cover the below molecule. So this one is here, this molecule is a chiral molecule. A chiral molecule, it's because its mirror images are superimposable. So this molecule is forming superimposable mirror image. That's why this molecule will be achiral. Okay, so that is achiral molecule. Now watch out about this compound. Here methyl is away from the observer, ethyl is towards the observer, OH this side, hydrogen this side. So when you watch out this mirror image, here this molecule is containing a symmetric carbon. As here C2H5, okay, this is not asymmetric, this carbon is also not asymmetric. But this carbon is bonded with a methyl group and a ethyl group. One hydrogen and one OH. So the 4 groups bonded to this carbon atom are different. So this carbon is asymmetric carbon. This carbon is asymmetric. Now watch out here, just verify that its mirror images are superimposable or non-superimposable. So what happened here? So OH is front side, so OH will be here. This hydrogen will be like in this manner here, in this manner. So that will be here. Mirror image will be like that. So what happened here? So this OH, so mirror image here, OH, this ethyl is towards the observer. So in the mirror image, the ethyl will be towards the observer. This methyl is away from the observer. So in the mirror image also, the methyl group will be away from the observer. This hydrogen is making some angle, actually 109.5 degree, towards suppose here in x dash y dash. So here in this one xy coordinate, this hydrogen will be. Position of this hydrogen is towards x dash y dash coordinate. The position of this hydrogen is in xy coordinate. So the position of this hydrogen will be towards xy coordinate. Here x dash y dash coordinate. So this one will be in x, in this direction. That means xy dash direction here. Now what happened? It's mirror image here. Watch out. When you rotate through 180 degree, so which is above towards the observer, that will become away from the observer, and which is away from the observer, that will become in the towards the observer, like this. Hydrogen making this angle, so here this angle here. Now when you keep this molecule over this molecule, then what will happen? Methyl will be over ethyl and ethyl will be over methyl. Yes, hydrogen will get covered, but and OH will also covered. But here methyl is above the ethyl and ethyl is over the methyl, so they are not superimposable. That means when you will watch out, then you can watch out this molecule also. Like that here eclipse, when that means here if this is a mobile and like that there will be another mobile. So if you will keep, if that will have symmetrical structure, then from the above if you will watch out, then you will not watch out this one. Just like that also, when you will keep one book over the other book, and if the length and breadth of the books will be same, then if you will watch out from the above portion, then you could not watch the books which is downward. And if the length and breadth of all the books will be different, then you could watch out the above books, as well as you will have the idea that there is also books at the downward. Okay, so same here, ethyl will be over methyl and methyl will be over ethyl. So this molecule will not completely cover this molecule. So this is non-superimposable mirror image. This molecule is forming non-superimposable mirror image. So this molecule is also chiral. And why this molecule is chiral? Because this molecule is containing asymmetric carbon. Since this molecule is containing asymmetric carbon, that's why this molecule is chiral, that is, it forms non-superimposable mirror image. Okay guys, it's very easy, not difficult. Enantiomers you know already. Enantiomers, what is that? The molecules which have same molecular formula but opposite optical activity. That means if one is dextrorotatory, then another one is levorotatory. Then that compound will be called enantiomers. Now one point here. The compound will be optically active or optically inactive. That you can predict by watching the molecule only. But the compound will be dextrorotatory or the levorotatory. That you could predict only by doing the experiment and not the asymmetric carbon atom or symmetric carbon atom. Okay, so the compound will be dextrorotatory or the levorotatory. That is experimentally determined quantity. Okay, now let's see. What is racemization? Recall that when I have taught you the reaction which was taking place through SN1 mechanism. What was happening when the reaction was taking place through SN1 mechanism? Then firstly there was cleavage of carbon halogen bond and formation of carbocation. The shape of carbocation became trigonal planar. Now there will be retention of configuration if the nucleophile will bond to that carbon from that direction in which the halogen was, and there will be inversion of configuration when the nucleophile will bond to the carbon atom opposite to the direction in which the halogen was bonded. Then there will be inversion of configuration. And if there be happening that same number of molecules of in the same number of molecules, there be inversion of configuration and retention of configuration. Then if one compound will rotate the plane polarized light towards right, then the other compound will rotate the plane polarized light towards left. So resultant optical activity will be 0. That molecule will be called racemic mixture, and that phenomena will be called racemic modification. That means the mixture of two enantiomers in the same ratio in terms of number of moles will be called racemic mixture. The mixture of two enantiomers in the same equimolar ratio, then That will be called racemic mixture, and the phenomenon will be called racemic modification. The mixture of two enantiomers in the same ratio in terms of number of moles or number of molecules. That will be called racemic mixture, and the phenomena will be called racemic modification. And that indicated by plus minus. That means the compound is optically active. Individually, both the compound is optically active, but when they mix in the same ratio, then the resultant optical activity will be 0. That will be called racemic mixture. This mixture will be called racemic mixture, and the phenomena will be called racemic modification or racemization. That process will be called racemization. Okay, that represented by plus minus. That means dextrorotating compound indicated by capital D, levorotating compound by L. If you confuse in the examination dextro D or levo L, so left, which the compound which rotate plane polarized light towards left, that means I start from L. So that will be levorotating. That also starts from L. Okay. Now let's see about this molecule, this compound. Very easy it is. No need to bother. Question is chiral and achiral molecule you will have to watch out. Okay. So now consider about this carbon, that is not asymmetric. That means this carbon is not asymmetric. Now watch out about this carbon. So here hydrogen, methyl, bromine and OH. So to this carbon all the four groups are different. So this carbon is asymmetric carbon. So asymmetric. So that's why this molecule will be chiral. Now about this molecule here. Here this carbon is not asymmetric. Now this carbon, one hydrogen, one bromine, here this also bromine. So these two same. So all the four are not different. So there is no asymmetric carbon atom. So that is this molecule is achiral. Now watch out about this compound. This one here, this carbon here. This methyl firstly, this methyl, that is not asymmetric because the 3 hydrogen attached to this one is same. So this carbon is not asymmetric. Now let's see about this carbon. So here OH, here hydrogen, there methyl, and here is 1, 2, 3 propyl it is. So this carbon is bonded with OH, methyl, hydrogen and propyl. So this carbon is asymmetric. This carbon is asymmetric. Now watch out here. This carbon, here 2 hydrogen, because nothing is there. So to consider about their valency, to consider about their tetravalency, so there will be 2 hydrogen bonded here. So both will be same. Now here also 2 hydrogen there, so that will be same. So this is not asymmetric carbon, this is also not asymmetric carbon. Now consider about this molecule. This methyl, the 3 hydrogen is same, so that is also not asymmetric. So in this case, there is only one asymmetric carbon atom. In this molecule, this carbon is asymmetric, so this molecule is chiral. Now watch out about this question. Just firstly enlarge this one. Now watch out about this molecule. Here is what? This methyl, because 3 hydrogen is same, so not asymmetric. This carbon, there will be 2 hydrogen, because 1 and 2 valency is satisfied. That means other 2 is hydrogen. So this is not asymmetric. Now consider about this carbon. Here hydrogen, here ethyl, here also ethyl. So this ethyl and this ethyl, 2 group has become same. So this is not asymmetric. Now this carbon here is also 2 hydrogen, not asymmetric. Here not asymmetric because 3 hydrogen same. So that is there is no any asymmetric carbon atom. So this molecule is achiral, while that molecule was chiral. Okay. Now let's see. Next question. In this molecule, chiral and achiral, let's see. This one is not a symmetric carbon because 3 hydrogen is same. Now let's see about this carbon. Here is methyl, here is hydrogen, 1 bromine, and here is ethyl. This is ethyl, this is ethyl, this is methyl. Here hydrogen and here bromine. So this carbon is a symmetric carbon. This carbon is asymmetric. So that means this carbon in this molecule there is a symmetric carbon. So that's why this molecule will be chiral. Now watch out in this molecule. Here is methyl, 3 hydrogen same. Here 2 hydrogen same, 2 hydrogen same, 2 hydrogen same. So there is no asymmetric carbon atom. So that's why this molecule will be achiral. Was that difficult? Not very easy. No, just proceed. Now that was about here. When the reaction takes place through SN1 mechanism and through SN2 mechanism. What is when there be inversion of configuration and when there be retention of configuration. So listen here. The reaction has been shown. In which here 1, 2, 3, 4. This CH2OH here, this one is shown. So that reaction here plus 1 chloro 2 methyl, that is dextrorotatory, and this one is levorotatory. Yeah, because OH is coming towards this one here in this molecule. The OH is coming towards this side. So that is minus here 2 methyl butane 1 all. That is. So this one here. This point, particularly the students who is preparing for the NEET examination, that keep in the mind. That is here in your NEET examination question we may ask, this compound is dextrorotatory or levorotatory. So this information very important for you. That means this information that 2-methyl butane 1-all is negative. That means levorotatory. That is important for those students who is preparing for JEE as well as who is preparing for NEET examination, and particularly to those students who is preparing for the NEET examination, question will directly ask which of the following compound is levorotatory. This one and 2 other options will be given. So you will have to keep in the mind that 2-methyl butane 1-all is levorotatory and 1-chloro 2-methyl butane is dextrorotatory. Dextrorotatory compound indicated by plus and the levorotatory compound indicated by minus. So these 2 points you keep in your mind. Okay? So this one keep in your mind, that is which one is dextrorotatory compound and which one is levorotatory compound. Now let's see here, when there will be inversion of configuration, what happened here? In this case, this molecule here, A and B here. How's inversion of configuration? I have already taught you, if the nucleophile will approach towards the alpha carbon atom from backward side, there will be inversion of configuration, and if the that means when the reaction will take place through SN1 mechanism and the process in which the nucleophile will bond to the alpha carbon in the same direction in which the halogen was present, then there will be retention of configuration. So how's racemic mixture will form? If the inversion of configuration and the retention of configuration, if both will take place in the same ratio, then there will be racemization. Okay, so that is here. So same process here, Also repeated when SN1 reaction takes place, SN through SN1 mechanism and SN2 mechanism, that has been shown. I have already discussed about that. Okay, so when there will reaction will take place through SN1 mechanism, there will be retention of configuration as well as inversion of configuration. That has been shown here. Nothing here difficult. There is no difficulty here. What is here? When reaction is taking place through SN1 mechanism, firstly there is formation of carbocation. Here, this form. Then after, if OH minus, the nucleophile OH minus ion will approach towards, in which direction? Based on that, like this one here. So on average, this one is, and here shape become trigonal, planar. This is above to the plane, this is below to the plane. If OH minus ion will comes towards the above, then, and when comes towards the below, that has been shown here. So that is based on that in which direction the nucleophile is approaching towards the alpha carbon atom. Based on that, there will be inversion of configuration as well as the retention of configuration. Okay, what is alpha carbon atom and what is beta carbon atom? About that I have already taught. Okay guys, so that was about the stereochemical aspects of nucleophilic substitution reaction. In the next class, we will discuss about the elimination reaction and the reaction with metals. It's all for the today class. I hope you have felt the topic which was very difficult. That means one of the most difficult topic of this whole of the organic compound. You have felt the AG, and now you might have, I hope you have realized that the topic about which you are bothered, that you have realized that those topics are very, very easy. Okay, so but even though if anyone have not felt comfort and he have felt any difficulty, then may consult to the Educate. Definitely the YouTube channel Educate will help you in this regard. It's all for the today class. Thank you, Team Educate.